Alright, good afternoon guys. These are going to be your notes for 12-3, Modeling with Linear Systems. There's no real background to this, it's just real life situations on what we've been doing so far. So number 1 says Tia has 25 figures in her China figures in her collection. The horse figures cost $2 each, and the cat figures cost $1 each. She paid $39 for all the figures in the collection. How many cats and how many horses and cats does she have? So we need to first write a system and second solve said system. What I like to do is first I'm going to find the totals because I know I have to have two equations, so I have to have two totals. So one says Tia has 25 China figures and the other says she paid $39. So I know that I have to have a total number of something that adds up to a total number of figures and something that adds up to $39. So as far as the figures goes, she had horses and cats. So H plus C equals 25. And then the figurines, we know that the horses cost 2, so that's 2H, and the cats cost 1, so that's plus C is 39. Okay, and I'm going to go off to the side here and I'm going to solve. And actually all I need to do is subtract them because the C's are both single. So I have H plus C equals 25, and I'm going to subtract 2H plus C equals 39 from it. H minus 2H is negative H, C minus C is 0, and 25 minus 39 is negative 14. So H equals 14. I'm going to take the 14 and I'm going to substitute it in the first equation. So 14 plus C equals 25. So C equals 11. So the solution is 14 horses and 11 cats. Example number 2 says Mr. Wallace has 32 models of antique cars. The Hupmobile models cost $5 each and the Duesenberg models cost $18 each. He paid a total of $264 for all the models. How many Hupmobile models and how many Duesenberg models does he have? So the first total that I come across is 32 models. And the second total is $264. So I need models of cars that add to 32 and money that adds to 264. So we're going to write two equations. The first one is got to equal 32 models. Well, the two types of models he had were the Hupmobile and the Duesenberg. So H plus D equals 32. And then we know that the Hupmobile costs 5, so we have 5H. And the Duesenberg models cost 18, so we have 18D equals 264. Okay, to get something to cancel, I'm going to multiply this top equation by negative 5. Okay, when I do that, I'm going to go over here to the side and show you. So we have negative 5H minus 5D equals negative 160. And then plus the 5H plus 18D equals 264. Okay, negative 5H and 5H cancel out. Negative 5D plus 18D is 13D. And negative 160 plus 264 is 104. Divide by 13. So D equals 8. And I'm going to fill that into my original problem because it's the most simple. So I have h plus 8 equals 32. So h equals 24. So my answer is 8 Duesenberg. D-U-E. And 24 Hupmobile. All right, we'll do a couple extra examples. You will have problems like this in your homework. It's going to come from page 452, number 6, and it says the sum of 5 times one number and 2 times a second number is 57. And then it also says the sum of the two numbers is 18. So from that we should be able to write a system and figure out what the first and second number are. So the first one says 5 times one number, so 5x, and it said the sum, so I'm going to add, plus 2 times another number, so 2y, is 57, and the sum of the two numbers, so x plus y, equals 18. Okay, I'm going to multiply this second one by -2. So I have 5x plus 2y equals 57, and -2x minus 2y equals -36. And I can add those together, and I get 3x equals 21, so x equals 7. And then I'm going to plug that into the second equation, so 7 plus y equals 18, so y equals 11. So you have your two answers. First number, second number. Okay. The next example is on page 451. It's your turn. Number 5. Bear with me while I flip pages here. Says a student has to buy graph paper and printer paper. The printer paper costs $2 a pack, while the graphing paper costs $3 a pack. She wants to buy at least 6 packs of paper, but wants to spend at most $27. Okay, so because we have the words at least and at most, we know that these are inequalities. So she wants to buy at least spend at most $27. So that would be 2x plus 3y, and we want it at most, so this has to be less than or equal to 27. And then she wants to buy at least 6 packs of paper, so x plus y has to be greater than or equal to 6. And then because these are inequalities, what we have to do is solve them each for y and graph to find the possibilities. So this would be 3y is less than or equal to negative 2x plus 27. Divide everything by 3, so y is less than or equal to negative 2/3 x plus 9. And then this one here, we just have to subtract the y, so y is greater than or equal to negative x plus 6. Okay, we're going to make our graph real quick. Okay, and going up the y-axis would be our graph paper. And along the x is going to be printer paper. Okay, so the first equation, y equals negative 2/3 x plus 9, so I'm going to start at 9 and go down to right 3. And obviously, maybe not exactly perfect because we made the bottom scale on our own. But I need y to be less than 9. So that means I'm going to shade to the left part of that line. And then my second line starts at 6. And the slope is negative 1. So... Ooh, I didn't quite get those right. Sorry, this is what happens when you eyeball things. There we go. Should end on 6. So. And I want y to be greater than 6, so that's up here. So we would shade in right in between our two lines, and that's the feasible region. That's possible answers. And that's printer paper. All right, your homework for this lesson. This is 12.3. It's on page 452 to 453, numbers 10 through 22 even.